looked at two-dimensional shapes in the previous videos, we found that they had certain properties. And one of the properties was area. So if you remember with a square, and then one property was the area that we measured by multiplying one side by the other side. And we also had perimeter, and that was the distance around the edge. And that applied to triangles and also polygons such as a rhombus and parallelogram. Well, now we've moved on to three-dimensional structures. They have other properties in addition. So one is volume and the other is surface area. And so we're going to look at each of these. I'm going to start off by looking at volume. And volume is often abbreviated to VOL. We then call it vol, we just say volume, but write it as VOL. And volume is the space within the 3D object. So here we have a 3D object, this cube over here, and volume is the space that is occupied in the middle of it. And the volume, the formula for working out volume is length by width by height. So length multiplied by width and multiplied by height. So for instance, over here, I hope this is clear enough. This is 1 centimeter by 1 centimeter by 1 centimeter. It's a cube, and the volume, substituting the numbers for the variables here, is 1 multiplied by 1 multiplied by 1. And when you do that multiplication, you end up with 1. And you always have to look at the units. So 1 watt, and we know it's centimeters because that happens to be a unit here. And with centimeters, we came across centimeters squared previously. Well, now this is centimeters cubed. So, and the reason is that if we were to write this out in full, this would be 1 centimeter by 1 centimeter by 1 centimeter, and so that would be 3. And so with indices, you add them. So it'd be 3, it'd be centimeters cubed. Let's look at this larger example of a shape. And this happens to be made up of 12 of these. So here are 6 at the top and there are 6 down at the bottom. And the dimensions then are length, height, and width or depth. Now sometimes they don't, if you look at an exam question, they don't mention width and height and all. They might just call it a letter. So that's A, that's B, that's C, for instance, over here. It doesn't matter because you can translate that in your own mind. So what is the volume of this larger cube? And so we can apply this. Length is here. So length is 1, 2, 3 centimeters, because each of these is a centimeter. That's 3 centimeters. The width is 2 centimeters, 1 and 2. And then the height is 2 centimeters, 1, 2. So 3 times 2 is 6. 6 times 2 is 12. So that confirms that this is made up out of those 12 little 1 centimeter cubed units. So I'd like you to have a go. I'd like you to calculate the volume of a cuboid of height 4 centimeters, length 5 centimeters, and width 3 centimeters. As usual, put the video on pause, and when you're ready, press play, and we'll work through this together. Okay, so I hope you've had a chance to work through this and it all makes sense. So what I like to do is, although these are just like figures, numbers, and a bit of text, I always like a bit of a diagram because I can visualize it better. So I know it's a cuboid, so I can draw out something like that. So that's what a cuboid might look like. The height is 4 centimeters. The length is 5 centimeters. And the width is 3 centimeters. And with this information, we can work out what the volume of that is. So the way there's so many ways of doing this, but we can work out, just apply each of these to this equation here. And again, it's good practice in an exam situation just to write out the formula. It all looks a little bit long-winded, but it helps to keep you on track because if the formula is here, you can always refer back to it. So let's substitute. So the length is 5 centimeters multiplied by the width, which is 3 centimeters, multiplied by the height, which is 4 centimeters. Now, as usual, I painted myself into a little bit of a corner. There's a little bit of space here. When you do this, you'll have much more room on your paper. So all of this. So 5 times 3 is 15. So 15 times 4. You don't have to do this in so many little stages, but I'm just doing it for an exercise. And then 15 times 4. Well, I know that 2 times 15 is 30, so 4 times 15 must be 60. And then we can't forget the units. So let's refer back now. So these are centimeters. There's 3 lots of them, and we multiply them together. So that must be 60 cubic centimeters, or centimeters to the 3, power 3. So that's volume. Let's have a look at surface area now. And surface area is the area that covers the surface of the object. So here we have a dice or a die, and it measures 5 centimeters by 5 centimeters, a pretty big one. And it's made up out of 6 faces. So this is a face 1, 2, 3, and then the other 3 you can't see, they're around the other way. Let's take out one of these faces, just put them here for the moment. So, surface area is the total area of the faces of the 3D object. In this case, they are all flat surfaces, but later on we'll come to curved objects. So, let's have a look at this. Let's start here. So, what is the area of this? So the area of one face is 5 centimeters by 5 centimeters. 5 5s are 25. Because they're centimeters and there's 2 lots, it's centimeters squared. So now we know the surface area of that, or the area of that. And we also know that there are 6 faces on this. So in order to find out the total area, total surface area, we have to multiply that by 6. So the cube has 6 faces, therefore the area of the cube is 25 centimeters squared multiplied by 6. There are 6 lots of those. And so that gives us a grand total of 150 centimeters squared. So I'd like you to have a go, and I'd like you to work out the surface area of a cuboid, which is the height of 4 centimeters, length of 5 centimeters, and the width of 3 centimeters. You hopefully should remember the values that we had in our example above. So put the video on pause, give it a go, and come back. So as always, let's draw this out again. And it's only a rough drawing. I think I can only do rough drawings. That's the bit. So this, because it's a cuboid, there's 6 faces. but it's not like a cube because these lengths are all different. So this has a height of 4 centimeters, a length of 5 centimeters, and a width of 3 centimeters. And we're asked to work out the surface area of it all. We can't do it exactly as previously because that applied to a cube. But I'm sure that when you see how this is calculated, it's more or less the same principle. So we have to do this. We have to realize that a cuboid has 3 pairs of sides which are identical. So this side and the one behind it are identical. This side and that one are identical, and the top bit and the bottom bit are identical. So we just need to do really 3 main calculations. So let's work out what the area of these edges are, and we can work that out from these dimensions. So 4 times 3 equals 12 centimeters squared. Now that's the area just of this, and we have 2 of them. We have one at the back. So multiply that by 2 and you get 24 centimeters squared. Let's do the same for this face over here. Now this is 4 centimeters, so this is 4 centimeters. So 4 centimeters multiplied by 5. This is 20 centimeters squared. And remember, we've only worked out the area of this. There's one set on the back. So let's multiply that by 2. And you have 40 centimeters squared. And then lastly, we're doing the top and the bottom. And so this is 3 times 5. So that is 3, that's 5. 3 5s are 15. And we have 2 of those. So simple case of totting them all up, 4 centimeters squared. So 4 plus 0 is 4. 2 plus 4 is 6. 6 plus 3 is 9. So it's 94 centimeters squared. Hope all that made sense. So lastly, we're going to have a look at a prism. And we met up with a prism before. Let's just change the pen to this. So what is the volume of this prism? So first of all, we have to do it again in 2 stages. First of all, we find out the area of one of the edges. So this is an edge. We find out the area. Now, if we were to make a copy of this edge and put it on top and flip it, it would form a square. So in fact, this is half of a square. So first of all, we need to find the area of that one edge. And so it is width, 5 centimeters, multiplied by height, but half the product. So that's where this half comes involved. So this is half multiplied the width by the height. And then if we substitute all the actual values for the formula into the formula, we see that the width is 5 centimeters, the height is 2 centimeters, so that's half of that. So that's half of 10, and half of 10 is 5 centimeters squared. And the last part of this, so that just gives you the area here. To turn that into a volume, all you have to do is multiply it by the length. And if you can imagine that cross-section, and we were to take a cross-section through here, we would see the same sort of structure as we do on the outside here. So here, yep, so the volume of this is the area of the edge, which you just worked out as 5 centimeters squared multiplied by the length. And so this is the length, and there's 4 centimeters. So 5 times 4 is 20, and that gives you 20 centimeters cubed.